Hello, everyone, and welcome. I'm Tom, and I'm incredibly excited to be here with you today.
And I'm Amy. We're thrilled to have you join us for a truly fascinating exploration into the mind of a brilliant physicist who consistently challenges our understanding of reality and, frankly, our preconceived notions about, well, everything.
Our mission today is really to navigate through this rich collection of insights from a recent conversation with Professor Andrzej Dragan. We're going to try and unpack his unique perspective on, well, everything from the fundamentals of physics.
Right, and the nature of truth itself.
Exactly, to the revolutionary impact of artificial intelligence,
Mm,
and even what it means to truly understand something in a world that's just getting more complex.
exactly. We have a lot of ground to cover, sort of extracting the most profound nuggets of knowledge and, honestly, some pretty surprising facts from his discussion. Professor Dragan has this remarkable way of turning incredibly complex ideas
Yeah, really complex stuff.
into deeply relatable, often startling insights. So settle in, because you're probably about to experience some serious aha moments that might just shift your perspective a bit. Let's delve in. 1. The unexpected path to physics. Challenging conventional learning.
Okay, so we begin our exploration with this mind-bending puzzle that Professor Dragan was presented with right at the start of his talk. It was almost like a philosophical warm-up. Picture this. A train is traveling at a pretty brisk 72 kilometers per hour,
Okay.
and a rifle bullet, moving at like a blistering 1 kilometer per second, pierces a 3-meter wide wagon perpendicular to its movement.
Right, straight through.
Yeah. And the question then is the offset distance of the holes left in the opposing walls. It sounds like a classic, maybe slightly intimidating physics problem, doesn't it?
Totally. The kind that makes you instantly think, okay, time for formulas.
Exactly. But what's truly illuminating here is how Professor Dragan immediately pivoted. He didn't just jump into the calculation.
No, he didn't. Instead, he connected it to that famous, almost legendary anecdote about the mathematician and physicist John von Neumann.
Oh, the fly story.
The fly story.
So-
Right. He recounted the well-known problem. Two trains speeding towards each other, and there's this fly buzzing back and forth between them until, inevitably, they collide.
And the challenge is to figure out the total distance the fly travels before the crash.
Right. And the usual trick to solving it is, well, elegantly simple.
Yeah, you just calculate the total time until the trains collide,
Based on their speeds and distance.
and then you multiply that time by the fly's speed,
Mm-hmm.
because the fly's speed is constant.
Exactly. It bypasses needing to sum this infinite series of the fly's shorter and shorter trips. It's like a classic think smarter, not harder moment.
But then, von Neumann, this absolute genius, when they asked him how he solved it,
He just deadpans, I summed the series.
which is just incredible.
It's so telling, isn't it? It highlights a key point that Professor Dragan emphasizes. Many problems often have both an incredibly difficult brute force solution and a surprisingly simple, elegant one.
Right, two paths.
And sometimes, like with von Neumann, a mind is just so powerful it can crush the brute force path, maybe even prefers it. For Dragan, this sets the stage for how he approaches understanding reality.
How so?
Well, sometimes the simple path is hidden. You need a perspective shift. Other times, the challenge just demands raw intellectual effort. It's about recognizing that obstacles can be tackled in different ways, and a truly curious mind explores them all.
Okay, that makes sense. But this leads us to something genuinely surprising about Professor Dragan's own journey into physics.
Oh, yeah, this part's great.
You'd naturally assume someone like him, a renowned physicist teaching at top universities.
Must have loved it from childhood.
Exactly. That it was his calling, a lifelong passion. But he revealed something completely different. He hated physics in school.
Hated it. Found it utterly discouraging, boring. He actually said he felt he was successfully discouraged from it for a long time.
Wow. That's a powerful statement, isn't it?
It really is. And if you connect this to the bigger picture of education, he passionately argues that traditional school systems often do harm to people's natural curiosity about physics.
Do harm. That's strong.
Yeah. He firmly believes there's absolutely nothing more fascinating than physics.
Mhm.
But not physics as like memorizing formulas.
Right, not the textbook stuff.
No. He defines it simply as a method of understanding reality. It's about genuinely grasping the fundamental truths of the world around us. He's pretty clear.
Yep.
Science, especially physics, is the best method we have for getting at that truth.
So his own path into physics then was,
Yeah.
well, it was pure self-teaching.
Completely. He just devoured popular science books, absorbed everything he could find, fueled by this innate curiosity that school had somehow managed to suppress but not kill. He recalls this pivotal moment years after hating physics in school, when a friend asked him, "What do you really want to do? What really drives you?"
And the friend pointed out
that everything he was deeply interested in, all the big questions he wanted answers to, was actually, well, physics.
And he describes this as a deep shock.
Yeah, a deep shock, which led him to buy proper physics textbooks and teach himself everything from scratch.
And then there's this story about spending an entire winter break just solving problems.
Like 100 physics problems a day, barely stopping for food. It just completely captivated him. It really speaks to that unquenchable inner drive, doesn't it?
It absolutely does, but it also raises this bigger smartphones, everything.
In a remarkably short time.
To a fundamental shift in our whole intellectual method. He describes it as moving away from just accepting truth on faith.
Right, where some wise person or authority just told you how things were.
And if you disagreed,
well, you might, as he puts it rather starkly, have your head removed.
yeah. So we move from that to constantly questioning, challenging, being relentlessly inquisitive.
In physics, he points out you don't get burned at the stake for heresy.
Now you get a Nobel Prize.
Exactly. Successfully challenging what everyone else believes, for overturning the established dogma. This critical, questioning, self-correcting approach just rapidly... computers back in the 90s. He even thought about it as a career before physics really took hold.
And his explanation for why assembler was so crucial back then is fascinating.
It wasn't just a choice, it was a necessity.
Right. It was literally the only language fast enough to make graphics display smoothly on those, well, primitive computers.
Yeah, the processors just couldn't keep up. Otherwise, higher level languages were way too slow for real-time graphics back then.
And now, he says, kind of amused, you wouldn't even program a cash register that way.
Puts the speed of progress in perspective, doesn't it? Just a few decades.
Definitely. And he draws this direct line from that early programming fascination, that need to understand how the machine really worked,
Under the hood,
to his current, really intense interest in artificial intelligence. The nature of knowledge and truth in a skeptical world. Okay, so building on his own experience, that, irrepressible curiosity he had, Dragan makes this really interesting point about nurturing curiosity in others. He doesn't actually believe in forcing it.
No, he suggests that real scientific drive, it just comes from within. Some people, he argues, are just so inherently curious about science that you simply cannot discourage them.
Like him, spending that winter break solving 100 problems a day.
Exactly. He almost asks rhetorically, I don't know if anyone needs to be encouraged to do science. The real challenge, he implies, is something else.
Which leads to flipping the question, right? Instead of asking how to encourage curiosity.
Maybe we should focus on how not to destroy it, especially in young people.
Yeah. And he makes this pretty pointed observation about people being full of opinions.
And the older they get, the more strongly they believe they understand things.
When statistically, in his, blunt assessment, their opinions are often complete nonsense.
He implies it's pretty widespread, especially now with so much information flying around.
And he gives this vivid, real-world example from his own recent discussions.
Right, talking to these leading figures at OpenAI in Krakow. People at the absolute cutting edge of AI.
Nobel laureates, top minds.
Exactly. And these brilliant people, he says, fundamentally disagree on the future of certain AI technologies.
Like completely opposite views.
Totally. One might say a specific technology is a dead end, pointless, no future. While another equally brilliant person claims that same technology has infinite scalability, no ceiling in sight.
Wow. Diametrically opposed.
And the implication Dragan draws from this is fascinating and kind of humbling.
What's that?
If two such brilliant specialists can disagree so completely, then, as he puts it, at least 50% of the content of their discussion is likely nonsense.
Because even if one turns out wrong, the other isn't automatically right.
Precisely. It highlights this critical point. Even the smartest experts make mistakes or work with incomplete data. It's a crucial reminder for all of us wading through information overload and confidently stated opinions.
Makes you really pause and think about certainty.
Absolutely. And this healthy skepticism becomes particularly relevant when we look at broader societal attitudes toward science. Especially now. Tom, you hold some pretty striking statistics from a recent report about Poland's relationship with scientific research.
Yeah, and frankly, it's pretty sobering. It paints a stark picture of the challenge.
What did it show?
Well, for example, almost 40% of Poles don't accept the overwhelming evidence for human evolution.
40%? Wow.
And 32% believe humans lived alongside
Dinosaurs.
Okay, that's quite a leap from the evidence.
Then there's 52% who don't believe in human-caused climate change, despite the global scientific consensus.
Over half.
By the internet.
those yellow subtitled videos he mentioned.
Exactly. Low-quality, conspiracy-laden stuff. He cited the recent claims about the Polish astronaut's mission.
Szymanski, that it was all just a green screen hoax.
Yeah, despite all the verifiable evidence, it just shows the battle for truth in the digital age.
But Dragan pushes back against the idea that humanity is getting, dumber.
Right. He thinks we're actually getting wiser overall.
So what's the problem then?
It's that the sheer, unfiltered flow of information now makes everyone's opinions, including the ill-informed, the weird, the just plain wrong, much more visible and accessible than ever before.
Ah, okay. It's amplification.
Exactly. His main takeaway from 400 years of science is this vital, almost desperate need to separate opinion from fact. He even avoids sharing his own opinions in scientific contexts.
Because there's a high chance they're nonsense.
Yeah. He says he's learned to mute his ears when people offer opinions because they're rarely useful in actually finding scientific truth.
Okay, but this leads to a critical question then. If specialists are often wrong and opinions are frequently nonsense, should we believe nothing? How do we trust any knowledge?
Right, and here, Dragan makes a really crucial linguistic distinction, especially clear in English, between evidence and proof.
Okay, evidence versus proof. How does he define them?
Evidence is like material support in court. It points towards something, suggests likelihood. Proof is more like a mathematical sequence. If A is true, then B must be
True, with absolute certainty.
Like 2 + 2 before is a proof.
Exactly. But empirical sciences, he says, they don't offer proof in that strict mathematical sense. You can't...
Absolute axiomatic certainties.
Right. So if science doesn't offer 100% proof, what does it offer?
It offers overwhelming evidence. A massive pile of data, observations, experiments that all point strongly in one direction.
Making alternative explanations incredibly improbable. And crucially, science tends to choose the simplest explanation that fits all that evidence. Parsimony. Occam's razor.
Like the flat Earth example. Why believe in this massive global conspiracy?
Involving millions of people, faked photos, rigged instruments.
When a spherical Earth is just a far simpler, more elegant explanation that fits everything we observe.
Exactly. And he uses the classic Copernicus versus Ptolemy example to drive this home.
Earth-centered versus sun-centered.
Right. Ptolemy's Earth-centered model did predict planetary motion, sort of, but it was incredibly complex.
All those epicycles, circles within circles.
1,000 assumptions, Dragan calls it. Basically a hidden, super complicated form of Fourier analysis trying to force the data into the wrong model.
Whereas Copernicus's sun-centered model
offered an equivalent description of motion that was vastly simpler. One clear, elegant assumption. That's how science really progresses. It seeks the simplest, most elegant, most economical description.
The complexity of Ptolemy versus the simplicity of Copernicus. Perfect illustration. 3. Pushing the boundaries of physics faster than light and beyond.
Okay, so now let's pivot from the nature of knowledge itself to what Professor Dragan is actually working on right now, his own cutting-edge research.
Yeah, this is exciting stuff. He's involved in what he calls a personal small project, but it sounds anything but small in its implications.
Right. He admits he and his team, some
Faster than light travel.
Exactly. It's been a cornerstone. Nothing faster than light. C is the speed limit. But Dragan says when you look closely, rigorously, at the 7 main reasons usually given for why FTL is impossible.
Reasons baked into our understanding.
Yeah. He's found ways to actually circumvent several of them. He's been checking them off the list one by one as potentially solvable problems.
Whoa. So what does this mean for, like, our basic understanding of the universe?
Well, the deeper they dig, the more convinced he and his team become that FTL may not be so fundamentally impossible after all.
Seriously.
Yeah. Classical physics doesn't seem to absolutely rule it out, though he admits it would lead to strange things.
Strange-like.
Strange things that surprisingly kind of resemble the inherent weirdness we already see in quantum theory. But the real sticking point, the big hurdle he's grappling with now, is in quantum field theory.
The really advanced map stuff.
Exactly. That's where the true challenge and maybe the final answer, yes or no, lies.
So the crucial question driving his research now is this technical aspect of quantum field theory, trying to overcome these mathematical difficulties.
And he freely admits there might be a fundamental reason at the end of it all why it makes no sense, why these things are truly impossible.
But he has to know.
He has to understand why. Is it a real barrier in nature or just a limit of our current theories? It's this profound exploration into the fabric of reality itself.
But it's not just theoretical curiosity, is it? There's a practical motivation, too.
Well, practical in a theoretical physics sense. He describes this fascinating observation he made within quantum field theory. Certain theoretical objects called tachons.
Those are the hypothetical faster-than-light particles, right?
Exactly. They always travel faster than light. He realized these tachons appear to be required for a specific, super important mechanism to work properly.
Which mechanism?
The Higgs mechanism, the thing that explains how fundamental particles get their mass, the one that won the Nobel Prize a few years back.
Wait, so tachyons are needed for the Higgs mechanism? That seems huge.
It's pretty remarkable, isn't it? And what's fascinating is that he noticed this relatively simple connection and was genuinely surprised no one had really described it properly before.
People just ignored it.
It seems they just glossed over it. Maybe because dealing with tachons opens up a can of worms, potentially weird implications people wanted to avoid. He saw it as this unexplained gap, a missing piece in understanding something we thought we had figured out.
So this creates this really peculiar situation for his research.
Totally. On one hand, he's tackling this incredibly hard math problem that a lot of people think is pointless. The voice of the people, as he says, thinks FTL is nonsense, a waste of time.
Right.
But on the other hand, there's this genuine scientific need for the description he's looking for. We need it to fully understand a fundamental piece of reality, the Higgs mechanism that we know exists and have experimentally verified.
So it's not just can we go faster than light. It's we need to understand these faster than light concepts to explain something we already know is true.
Exactly. That strong underlying motivation, that scientific necessity, fuels his work on this seemingly impossible problem. It's not just abstract possibility. 4. The impact of artificial intelligence, a new era of understanding and ignorance.
Okay, let's shift gears now to artificial intelligence. AI. A field Professor Dragan apparently dabbled in recreationally like 30 years ago.
Yeah, long before it was the massive thing it is today. He talks about programming early AI systems, genetic algorithms, just as a personal hobby. And even back then, he was surprised by what they could do.
But his current take on AI's impact is, well, it's radical. And maybe a little unsettling.
It really is. His core claim is that the fundamental revolution with AI is that our ignorance has ceased to be a limitation.
Our ignorance is no longer a limitation. What does that mean?
He explains that historically, if we didn't understand the basic principles of something like electricity for someone in the Middle Ages trying to build a computer, or general relativity for designing accurate GPS.
That lack of understanding stopped us from building the technology. You had to understand it first.
Right. But AI flips that. We can now build things, powerful things, without fully understanding how they achieve their results.
Okay, example.
AlphaZero, the DeepMind chess program. Co-created by Demis Hassabis, who, fascinatingly, won a Nobel in medicine as a programmer.
Right, AlphaZero. It taught itself chess.
Entirely through self-play, no human rules, no strategies, no openings programmed in, and in just 40 minutes of training against itself.
It could beat world champions.
And
the best human-programmed engines.
Exactly. Dragan points out you could start that training algorithm without even knowing how to play chess yourself. That highlights the disconnect. Programmer knowledge versus AI capability.
Okay, so connecting that to the bigger picture, it means we can create training algorithms
that produce programs capable of doing things the programmer cannot do. Or maybe can't even fully understand.
Right, he uses the analogy with biological evolution.
Yeah, it's a great analogy. We understand how a frog evolved, natural selection, DNA mutations, we get the process.
But we don't really understand how a frog works in its entirety. How every cell functions, how its brain works, the whole system.
Exactly. We understand the process of creation, but not the intricate details of the product.
So what does this mean for AI then?
Similarly, he says, machine learning experts understand the training algorithms for neural networks. They know how to set them up, how to feed them data.
But they don't understand how the training network itself actually operates internally.
No. How it arrives at its decisions, how
It processes information, the complex dance of its millions or billions of parameters. It's largely opaque.
A black box.
The black box. He finds this level of misunderstanding.
of AI capabilities everywhere.
Generating images, video, voice, solving complex problems.
Right. He points out the core algorithms for image recognition, for instance, were actually discovered way back in the late 80s.
Really? So it's not a new understanding?
Not fundamentally. It's mostly the exponential leap in computing power and the massive amounts of data we now have that allows those old algorithms to solve problems that were just impossible back then. We just scaled them up, and they revealed capabilities we didn't fully anticipate or design in.
Okay, so this leads to his counterintuitive point about AI's impact
on human work.
Right. While AI clearly makes our lives easier in many ways, automating tasks, convenience, like asking ChatGPT to plan your vacation.
Yeah.
So what does that leave for humans? Only the difficult parts. The creative work, the strategic thinking, the complex problem solving, the stuff that isn't easily automated.
Takes away the easy bits, leaves us with the hard bits.
Exactly. He uses the example of his own writing. He uses AI to handle the ungrateful part, grammar, correctness, readability, freeing him up to focus solely on the truly hard creative part. The actual scientific ideas, the intellectual heavy lifting.
So the overall difficulty level of human work just keeps increasing.
That's his argument. Technology constantly pushes the bar higher. He contrasts it with jobs 300 years ago, a blacksmith, a peasant maybe needing weeks or months of training.
But now to be a scientist, an innovator,
requires 10 years or more of intense learning, continuous skill development. Our work isn't getting less demanding, it's getting more complex, pushing us towards higher level, more abstract skills.
Which raises that profound, maybe slightly unsettling question for us, the listeners.
Right. If AI keeps automating the easy parts, are we heading towards a point where the remaining work is just too difficult?
Too difficult for most people, maybe. It's a challenging thought about the future of human contribution. 5. Insights from audience Q&A. Education, reality, and the human condition.
Okay, moving into some questions from the audience during his talk. The first one came from Monica from Shasine.
What did she ask?
She asked about the differences between education systems in Singapore, where he also works, and Poland, and what changes might be beneficial for Poland based on his experience.
The big fix the
system question. How did he respond?
True to form, he politely sidestepped giving sweeping advice to entire nations, said it's generally ill-advised for one person to tell
It's a matter of people.
Exactly. The system is often just an easy scapegoat.
And he had an example for this, right? The physics Olympiads.
a powerful one. For years, setting tasks for these competitions, he noticed certain cities consistently produced way more finalists, year after year.
And the reason wasn't the city's system.
Well, it turned out to be a single brilliant teacher who had moved between those cities. One person made that much difference.
Wow.
He also highlighted that apparently half of OpenAI's creators are Polish.
I didn't know that.
And some came from one specific school where an informatics teacher used an original teaching method and basically mass-produced geniuses, as Dragan put it.
So the takeaway is, it's not about top-down systemic changes.
Not primarily. It's about the incredible, almost catalytic impact of individual inspiration. Great teachers, he says, are an absolute treasure.
They ignite passion, curiosity, change lives, regardless of the system.
Exactly. They're the true bottleneck, the most valuable and sadly often scarcest resource. A powerful point about the human element.
Definitely. Okay, next question.
Arter asked something provocative. He noted some of Dragan's concepts seem almost mystical, like three-time dimensions.
That sounds pretty out there.
And Arter asked, does Dragan have proof or evidence that we might be living in a simulation like the Matrix?
The simulation hypothesis. What did Dragan say?
He stated very plainly he has no opinion on it as a scientific theory, but he made an interesting philosophical observation.
Which was?
That, in a way, all religious people believe in a simulation theory, some higher being creating rules and observing. He classifies it as a fundamentally mystical question outside testable science.
And reiterated his stance on opinions being worthless in science.
Yep. Said he can't offer proof or evidence precisely because it's not empirically testable science.
Okay. Then another caller asked about that phrase, maybe it's like this,
Which Dragan clearly dislikes.
and how it relates to science fiction.
Dragan admitted he avoids popular sci-fi, not out of disdain, but because he fears it would just consume all his time.
Relatable for many researchers, probably.
Probably. But he explained his aversion to, maybe it's like this, in a scientific context. Such speculation is useless unless
Unless what?
it connects to a real phenomenon that current theories can't explain. A&D proposes testable predictions. Predictions you can go out and check with experiments.
So theory without potential verification isn't science for him. It's just speculation.
Exactly. It doesn't exist as science until it's testable.
And he also talked about time itself.
Yeah, delved into how little we actually know about what time fundamentally is. It has different, even contradictory roles in quantum theory versus general relativity. They don't even mesh properly.
And in relativity, there's no universal now, right? The whole timeline exists.
Effectively, yeah.
Yeah.
An object entire trajectory exists. Our perception of time flowing, he suggests, is just metaphorical and often clashes with how physics describes it.
And this connects back to his faster-than-light research again, doesn't it?
It does, in a really fascinating, mind-bending way. He explained quantum physics describes matter as waves spreading out spherically like ripples.
Huygens' his principle.
Right. Now, imagine a hypothetical faster-than-light observer. From their mathematical viewpoint, time and space would essentially swap places. They become interchangeable.
Okay, that's right.
Gets weirder. The bizarre quantum rule about a particle moving in all directions in space at once.
Becomes what for the FTL observer?
It becomes a particle moving in all directions in time.
Whoa, moving in all directions in time.
Suddenly, he says, these nonsensical theses about
Several time dimensions, which sound like pure fantasy,
Yeah, totally.
when examined closely, begin to look quite reasonable within this consistent mathematical framework that allows for
Others are just training, honing skills.
Depends on the problem type.
Yeah, Newtonian problems often involve visualizing forces, applying formulas, Quantum problems are about predicting probabilities, needing a different, trained quantum intuition.
And you mentioned that paradox about intuition, right?
Newton's laws feel intuitive to us because of daily life, but quantum theory feels totally counterintuitive.
Yet quantum laws are actually simpler, fundamentally, and Newton's laws derive from them.
Exactly. He likened problem solving to a chess grandmaster.
Or a fencer. So much becomes automatic, almost mindless reflexes built over years. Only truly new problems need that slow, deliberate system.
Unproven or undecided is arrogant.
So the scientists don't believe in quantum mechanics or relativity.
No, he says they're forced to accept them. Not by faith, but because experimental reality compels them to. The evidence is just overwhelming, despite how weird the theories seemed at first.
And the scientists are constantly trying to disprove them.
Constantly performing experiments designed to break the theories, but after 100 years, nobody succeeded. So it's not belief. It's what he called an unpleasant necessity forced by the data.
Which leads to that profound thought about science being a chain of fascinating disappointments.
Yeah.
We look for certainty, determinism, maybe,
Yeah.
and we find probabilities, uncertainty. The Nobel Prize for proven quantum physics is probabilistic might seem sad if...
His advice was basically, don't fight the inevitable, don't fight the horse.
Adapt. Figure out how to use it wisely.
Exactly. He loved the example of a teacher using ChatGPT essays not as final products, but as starting points for students to improve upon, leveraging it as a tool for creativity and refinement.
And for his own work.
He called AI a great salvation for the most ungrateful part of writing papers, the grammar, the correctness, the polish.
So he writes his ideas down rough.
Yeah, quickly gets the core concepts down, then feeds it to an AI to civilize the text, streamlines the tedious part, saves time for the real thinking.
Which ties back to his earlier point about AI making work harder.
Right. It directly counters that popular idea that AI makes work easier overall,
Because it automates the simple stuff.
leaving us humans with only the more complex, creative, difficult parts. The overall difficulty level of human work just keeps ratcheting up with technology.
Okay, almost at the end here, a caller observed that Dragan seemed to have loosened up his views on the fundamental rules of the universe.
How did he respond to that?
He said he didn't feel that way at all. He's always been clear that we know very little, that ignorance is generally the rule and understanding is the exception. Humility has always been his stance.
And he cited the poet Wisława Szymborska.
Yeah, her beautiful, grounding description of humanity as unwise meat. He said that perspective has always resonated with him, kept him aware of our limitations.
Unwise meat. That's memorable.
It is. Then the final internet questions were the classics.
Let me guess. End of the world predictions. Are we real?
Got it. On predictions, he basically said, forget it. Predicting the future is senseless. Now it has ended because change is too fast, too unpredictable.
Even the experts get blindsided, like Hinton with GPT-3.
Yeah, exactly. The only reliable predictions are those super long-term trends, like the falling cost of information over millennia.
And on existence. Are we an illusion?
He believes something exists, but it's definitely different from what it seems to us. Our current fundamental laws are likely just temporary illusions, approximations of a deeper, stranger reality.
Always pushing towards a deeper unknown. What about space experiments?
Ah, yeah. He mentioned visiting a lab in Shanghai, working on quantum experiments in orbit.
Cool. Testing quantum gravity?
Apparently not really feasible in orbit.
Yeah.
Gravity's effects are too weak at the quantum level there. The results are pretty much the same as on Earth for most things.
So what do they test?
Things like quantum teleportation, quantum cryptography over large distances, and the consistent result, quantum theory still works perfectly.
So even when we push it into space, the strange rules hold up, which raises that question. Science keeps pushing, keeps testing, even when the simple answers are elusive. The search continues.
Wow, what an incredible discussion. I really feel like we've just scratched the surface of Professor Dragan's insights, but what a rich surface it is.
Absolutely. His perspective is such a powerful reminder, isn't it? That real understanding, it doesn't come from just accepting things. It comes from questioning everything, embracing uncertainty,
Yeah, being okay with not knowing.
and constantly seeking those simpler, more elegant explanations, even when the answers are, well, weird or totally counterintuitive. His work really shows that our ignorance doesn't have to be a limitation.
No, it can be a catalyst.
Right, a catalyst for discovery.
Exactly.
Mhm.
And perhaps that's the provocative thought for you, our listener, to maybe ponder after this conversation.
Yeah.
If our work is destined to become increasingly difficult as AI handles the simpler stuff,
Mm-hmm.
what kind of new human creativity, what kind of new problem-solving skills will be unleashed by that constant challenge? And maybe what will that mean for the joy we find in our work as it becomes less about routine and more about pushing the boundaries of what only we humans can do?
Thank you for your attention. You can subscribe our podcast if you like it.
See you next time.